Hi everyone! In the previous section, you successfully started your backend and set up a process manager. Your API is alive and listening on a Unix socket file. However, your users cannot access your website. Your frontend is also just a folder of static files sitting on the server, waiting to be served. In this subchapter, we are going to talk about reverse proxy and security headers. First, we need to sync the frontend and the backend URLs. After that, we will install Nginx to act as a reverse proxy. I will explain this once we install Nginx. I'm going to explain to you what does 502 bad gateway means. So this is an error that we might get if we don't set up Nginx correctly. And finally, we will move to the security part. In this subchapter, we are going to focus only on the HTTP security headers, mainly CSP, and there are other ones. But CSP is the one that requires a lot of work, and we will focus on it at the end of this video. Now let's SSH to the machine because we need to start by syncing the frontend and backend. And I will come back to the slides if I want to explain some diagrams. As you can see, I am logged into the machine, and before we configure Nginx, you need to prepare your code. You want your frontend and backend to act as if they live on the exact same server, both in local development and in production. This avoids complex cross-origin issues. Let me show you what I am talking about. As you can see, I need to go to the web app directory because last time we moved the source code here. I will change ls to cd. Now I am inside that directory. Let's start with the frontend. Let's go to frontend, and here we need to go to source, and we have main.js. So we need to open that file. Let's use nano, and let's see. As you can see, here we are using an environment variable, Vite API base URL. Let me show you the content of that variable. Let's do ls, and here I need to go back to frontend because here we have the environment file. As you can, so let's do ls-la. Yeah, you can see that we have .env.example, and we also, from that we create the .env file. But let's look at .env.example by using cat. So let's provide the file. And as you can see, this is what we have here. The backend runs on this port. When you are developing this locally, the backend will be running on a different server. And in the frontend, we use Axios to make HTTP requests. And it needs to know where the API lives. And here it lives in port 8000. This is good, but it introduces cross-origin issues. If we try to send a request to this port, the browser will block it because it sees that you are trying to communicate with a different origin. And even though we are running on localhost, it's not going to be allowed because the frontend runs on port 8080, but your backend runs on port 8000. So that's how I started developing this, but I will show you a simple way to avoid this problem. We are going to use Vite. And with Vite, we have something called Proxy, and it will make this very simple. So this .env.example, we no longer need it. That's why I wanted you to open the main file and change it. So let's do that quickly. Now you can see that here I am using Axios, and the base URL, we set it here. I will remove all of this. I don't need it. And here, instead, I will just put /. By doing this, the browser will automatically send requests to the current host. So if I'm running on localhost, this will tell the browser to send it to localhost. If I am running on my domain, it's going to be that domain. That's the first change that we need to make. Now save the file, exit with Ctrl X, Y, and enter. Great. Now we need to configure Vite. So let's look at Vite. It's not here. It must be here. Yes, so we have Vite config. Let's open it with nano Vite config. Now I want you to scroll down. Here you can see that we have server, and this is where we set the port. By default, Vite starts on a different port, I think 4000 something, but I usually change it to 8080. And here we can add another field to the server block, and we call it proxy. Here is the field that we need to add to server. You can see that it's called proxy. And here the backend API is, it has this prefix /API. And we tell Vite to send that request to this URL or to this target. This means that if the frontend tries to send a request to the API, Vite will intercept that and target this URL. This way, we can change origin without having to worry about cross-origin issues. Let me explain this with another diagram that I created. You can see that here we are on a local machine. We are developing the web application. And here I am using, let's say, Chrome, and I want to make an HTTP request. So I am in the browser. If I want to load static files, basically the web page, I will be here. So the path will not be API. I will just talk to the front end. The front end will send back the HTML, CSS, and JavaScript files. Vite will take that and send it back to the browser. And the browser will display the website for me. Good. But let's say that I want to search for an article or something. That request will need to talk to the backend. So Vite will see the request that I'm trying to make, or the browser is trying to make. If it sees that it has this prefix /API, it's going to send it to the backend. So Vite sits between the browser and your front-end and back-end servers. And this implementation solves the cross-origin issues. Awesome. Now we need to go to the backend. Let's do that quickly. So we are in the backend folder. Let's see what we have. So we need to look at main.py. Let's open it with nano. And here we need to remove some things. You can see that here we have a coarse middleware. This is what we needed before using the proxy feature that Vite gives us. So we need to remove this class. And now let's go down a little bit, because here, as you can see, we used that middleware here because we allowed the following origins. So this block, we need to remove it. And in order to do that, hit Alt-A, go down and hit Control-K. That will remove those lines. Now we need to save this and go back. Okay, so now we don't have coarse issues. The front end will be able to communicate with the backend, because as you saw, we used the proxy feature that Vite comes with. So after making this change, the backend, we don't need to do anything in the backend, but the frontend must be built again. So we need to build the frontend. So go back to the frontend folder and run pnpm build. Why we need to do that? Because the build process will regenerate the HTML, CSS, and JavaScript files, and it will bake in the changes in those generated files. But the backend doesn't need that because it doesn't have a build step. So just run pnpm build and let's wait for the build process to finish. Awesome, the build finished. Now the first step in this video is done. We synced the backend and frontend URLs, and now we can move to using Nginx. But why do we need Nginx? Nginx, you can think of it as a front door for your server. When a user types your domain name into their browser, the request will hit Nginx first before loading HTML files or before talking to the backend. So Nginx is going to intercept that request, and it's going to act as a reverse proxy, meaning it will decide what to do with that request. Let me show you another diagram that I created to explain this in detail. I am back, and let's go to the next slide. Here is the diagram that I created in order to explain why we need Nginx. As you can see, it's similar to the diagram that I showed you that explains Vite proxy. Here we start with the user, with a browser. We send a request. Before talking to the front end or backend, Nginx will intercept that request. If it sees that the path is /API/something, Nginx will talk to the Unix socket, and that Unix socket will send the request to JUnicorn, and JUnicorn will send it to the UVcorn worker, which runs our backend. You can see that this is the part that we talked about in the previous subchapter. Let's go back. Here, when we talked about SSH tunneling, we mentioned that the frontend is running here and the backend is running on the server. And we explained how that works. We have the supervisor, we have JUnicorn and our workers. And here we mentioned that we created a Unix socket file, and I told you that I will explain to you where that will be used. And in this video, we are using that to communicate with Nginx. Let's go back. You can see that we have JUnicorn. Here I simplified the diagram. I am showing just one worker, but you get the idea. You have your Unix socket. It is used in order to allow Nginx and JUnicorn to communicate between each other. You can see that here in the description, I said it's a two-way pipe connecting Nginx and JUnicorn. So let's say that the user is searching for an article. Let's say that the endpoint is /API/articles. That request will be intercepted by Nginx. It sees that it has the /API prefix. It's going to send that to JUnicorn, but it's going to do it through the Unix socket file, because here we are inside the VM, and in order for two programs to communicate with each other, we used Unix sockets files. So now the JUnicorn receives a request to the /API/articles endpoint. It's going to give that to the FastAPI endpoint. If we have an endpoint, great. The code will run. We'll try to fetch articles. Now we will send that response to Nginx. So we will move, the response will go to JUnicorn, we'll go through the socket and back to Nginx. Nginx sees the response, is going to send it to the browser, and yeah, you will see articles. So that's why here we use Unix sockets, and you can see on the other side we have just the static files. And if we have a request to an endpoint that doesn't start with /API, we will go here, we will fetch the static files, which are HTML, CSS, and JavaScript, and the browser can display that. So that's why we need Nginx. And as you can see, it works like Vite, but this runs on production. You use Vite locally when you develop your application, but on the virtual machine or on the DigitalOcean droplet, we use Nginx. It's the same concept, but one runs on your laptop and the other one runs on the virtual machine. I hope that my explanation was clear. Now let's install Nginx. We will do it this way. We are on Ubuntu, so we can install this directly from the repository. I will provide my password and let's wait for a few seconds. Awesome, we installed Nginx. You need to understand that Nginx uses configuration files to know how to route traffic. Let's create a new configuration file for your website in the sites available directory. So let's do this. Sudo nano etc nginx, and we have a directory called sites available. And here you put your project name. Let's call it my website, maybe .com, _com. We are going to build this configuration block by block so that you can understand everything. Let's start with the upstream block. As you can see, I just copied it from GitHub, and we just need to change this placeholder. I will use the same name that I used for the configuration file. And if you are wondering where to get the code or the things that I copy paste, you will find them on this GitHub repository. Here it is. So if you go to full stack deployment handbook, you will see that here I am documenting everything. click on the book folder, and here you have the chapters. So far we completed chapter 1, now we are in chapter number 2. So if you click on the second markdown file, let's search for upstream. You can see that here is the upstream block. You can copy it from here and paste it in Nano and go from there, so that you can go quickly. So don't worry about the code, everything will be shared in the video description. First, as I said, start by changing that placeholder. Here I use my website.com, but you can use any other name. So this acts as a variable that we can reuse in other blocks. Instead of typing every single time Unix, web app, etc., we will just use this variable to make the code clean. Here you can see that so here this is a variable, here we have fail timeout is equal to 0. This is an important setting because it tells Nginx to never mark the backend as down, even if it fails to respond. So if you have a lot of traffic and your backend is starting to respond slowly, sometimes the Nginx will drop the request if it doesn't respond quickly. But here we tell Nginx, don't worry, even if the backend is down, don't fail. Okay, now let's add a different block. It's called the server block. This tells Nginx to listen for incoming web traffic on port 80, which is standard HTTP, and to respond when someone asks for your specific domain. Right now, we haven't created a domain name, but that's not a problem. We will use the droplet IP here in the server name. But later, this will be changed from the droplet IP to the domain name. So let's do this. If you don't know how to get your droplet IP, we have different ways of getting this, but you can go to DigitalOcean, make sure to log in. Here in the project, make sure to select the project where you created the droplet. And here, as you can see, we have the IP address. So copy it and let's go back to Nano and let's paste it here. I will remove this and replace it with the droplet IP. You can see that we also have some log files, and here we need to change this. These are also placeholders, and here I will use again, let me copy this, my website.com, and let's place it here. Let's also do it here. This is helpful because if something breaks, we can check the error logs to understand why that happened. Here I have a comment that says we will add the location block, some other blocks here next. But as you can see, we are doing this step by step to understand every line that we are writing. Okay, now I will remove this comment. Again, I will use Ctrl-K to do that. And let me place the location block. Remember, here we have slash, which means that we want to serve the front end. If I open the browser and go to this IP address and I add a slash at the end, Nginx will catch that and will serve my front end to the user. Now let's try to understand what we have inside. Here we have root. This tells Nginx where to look for files. In this case, it points to the dist directory because when you run pnpm build, the files that are generated are going to be inside the dist folder. Try files is important because here we have a single page application. It tells Nginx to find the exact file the user asked for. And that file is going to be here, $URI. If it is not there, it's going to look for a directory. So if this is a directory, it's going to look inside it to find the file. If it can't find the file, it's going to use index.html as a fallback. Let me explain this. So here I have my personal website. I can open it. You can see that here we have slash at the end, which means that we are serving the front end files. If I want to open something else, like maybe my resume, I can do it. So I can do slash resume and you can see we get it. But how does this work? If I go back to the machine or to the VM, let's save this file. Let's hit Ctrl X. Let's look at the dist folder. What do we have here? You can see that I have a lot of files. So we have some images. We have robot.txt. Let's also try to get robots.txt. Robots.txt. You can see that I am able to see this file. Why? Because Nginx knows where to find those because of this. Let's go back to nano because of this location block. So try files will URI will be robots.txt, and we know that we should look inside the dist folder. If we find it, good, we will show it. But if we can't find it, we will show index.html. Okay, and yeah, index.html is also should be here. You can see here it is. So that's the reason why we added this location block, and this will serve your front end. We will do another one for the backend, and it's going to look for /API instead. I will copy it and I'll paste it here. You can see that it is similar. We will use the location block, and instead we will look for /API. Okay, now we have a lot of directives. These are called directives. So proxy pass is a directive, and here we need to change this placeholder from your project name to this string. So proxy pass will hand the request over to your JUnicorn socket. That's what I explained in the slides. We are here. So we use the Unix socket to allow Nginx to forward the request to JUnicorn. And this is what we are doing here in this directive. The proxy set header, we have two of them, are crucial here because they take information about the real user who is trying to access your website. Because if we don't do this, we will send the IP address of your virtual machine, and we don't want to do that. And finally, we have proxy redirect of, tells Nginx to trust the redirect URLs exactly as your backend sends them. So if your backend tells Nginx to redirect, Nginx will trust it. It's not going to do something else. Okay, great. So now we have we have two locations, one for the front end and one for the backend. So we can save the file and let's exit. We have two options to test this configuration. We can do it live here on the server, but if you aren't unsure, or if you already have a working website and you want to introduce changes to your configuration, if you have a mistake or if the configuration is false, that will cause downtime, and we don't want that. There is another option, which is to use a website called Nginx Playground. Nginx Playground is a website that allows you to simulate your routing rules safely in your browser without having to do this on your production server. You can see that here we post the Nginx configuration. Here we have events, HTTP. As you saw, we didn't write these. I'll explain to you why, but we need to add them for the configuration to work. The blocks that we created are these. We created server, location, we created two of them. Here we are listing on 80 because we used HTTP. Here we are serving the front end, and here we are serving the backend. This playground has a built-in testing backend running on port 7777, and we can use this as our backend. Here you write your curl commands to send HTTP requests. We'll start with localhost. Make sure to use localhost. You can't use your own domain because this is a playground and we are testing things internally. To test the curl command, you hit run. And as you can see, the output says serving Vue.js files, which is correct because here we have / and this location block will catch that, and it will, in this case, return this string. But let's add maybe something else. So let's add API v2. Will this work? Let's see. Let's hit run. And that works because here we have /API, and that catches this. And here you can see that we have, this is a response from the backend. Let's do something else. Maybe let's do API /v1 or /articles. Let's remove this. Let's send the request, and it works. So this block will catch this, but maybe let's do something else, like maybe a resume or something. Yeah, that will be catched by this block. So everything is working. And if you add complex, I don't know, if you work on complex configurations, this playground will be very useful. So we know that our configuration works. Now we can close this, go back to the VM, and I want to tell you why in our configuration we don't have the events block and HTTP. Okay, let's close the file. And here on Ubuntu, we use a modular system for Nginx. There is a master configuration file located here. Let's look at it. Let's do cat etc nginx nginx.config. Hit enter. So this is the master configuration file. Let's scroll to the top. You can see that we have events. It's already here, and we have the HTTP block. And if we scroll down, we include some things. And what do we include? If you look at this path, it's etc nginx sites enabled. Here we have an asterisk to load every configuration inside that directory. And if you remember, the configuration that we created is inside this folder. So that means that this master file will load our configuration. That's why we don't need to add events or HTTP. It's already there. And one thing that you need to understand is that the Nginx will run as this user. It's not going to run as my user or the user you created. No, it has its own user, it's going to use it. So it's www-data. Now we need to enable this site. Let's see. So we have sudo nano, okay, good. But I want to use ls instead of nano. So let's see what we have inside the Nginx. You can see that we have two folders. We have sites available and sites enabled. So sites available, we define the configuration just so that Nginx knows that there is maybe a configuration that it needs to take into consideration. But for it to work, we need to put it in enabled. And here we are not going to copy paste it because that's not a good practice, because you will need to maintain both. Instead, we are going to use a symbolic link. This is just a shortcut that will put that file here. And if we want, we can just change the configuration inside sites available, and that change will take effect in the other directory. So we'll have it in two places, but we can change it once, and it will take effect in other places. Here is how we create a symbolic link. We use ln-s. Here we need to change this. Let's see, I need to put my configuration, the name here. Let's go here and let's do it in sites available because I can copy it easily. Let's copy this and let's paste it inside sites enabled. So we are creating a symbolic link from here to this directory. Now hit enter. Great. Let's look at, let me copy this or let's copy the other one. Let's do etc, and here I will add ls-la. And as you can see, here it says L, which confirms that it's a symbolic link. And as you can see, we have this. It is pointing at this file, which means that if this file changes, this file will also change because it is basically a shortcut. We are almost ready. So now we need to make sure that the configuration is correct. So run this command. And what you should see is this. It should say that the syntax is okay and that the test was successful. If you see an error or something, please fix it, because if you use a configuration that is not correct, your website will not work, or people will not be able to access your website. Awesome. So now let's reload Nginx so that it can read the configuration. And now we cannot access the website. So I can take my IP address. Let's copy it. Let's go here and let's paste it. You can see that it's not going to work because we have the firewall. We need to allow traffic through port 80. And in order to do that, we can do this. We can allow Nginx. We use sudo. Here we use the uncomplicated firewall and we tell it to allow Nginx. Let's do that. Okay. And now let's verify the status. Sudo ufw status. Before, as you can see, we had just open SSH so that we can SSH to the machine, but now we also have Nginx, which means that we can talk to port 80. Now, if I go to the website, as you can see, it's already worked. Before it wasn't working, it couldn't find the machine, or the firewall was blocking it. But now, as you can see, I can refresh the page and I see the front end. You can see that the website is not secure because we are on HTTP. We'll solve this in the upcoming chapters. And as you can see, we have some errors because we don't have articles yet in the browser, in the application. But the front end is running and the backend is also running. So if I click on blogs or courses, you can see we cannot get them because they are not here. And in my web application, I am using Melisearch, and we will talk about that in the next chapter. But we also have a problem here. So let's see. So if I open the console, let's zoom in a little bit. You can see that I am not able to make a request to the API endpoint. Interesting. So let's go to the VM and let's understand why is this happening. Remember, we added log folders. So here, let's do this. You can see that here we have error logs for our website. Let's take this and let's put it here. And let's look at what we have here. We don't have anything. Okay, that's interesting. And let's look at access. So here, access log, that's me trying to access the website. So you can see that I made a post request to these endpoints. So here we have tracking and here we have search. And yeah, and I was using Mozilla. I'm using Firefox. So yeah, that's what you see in the access logs. But we don't see any errors. Let's look at the supervisor logs. For that, we need to go to Backend. Let's see. Yes, we have logs. Let's go inside. What do we have here? We have supervisor.log. So let's do tail supervisor.log. And as you can see, we see the problem. So here it says that failed to establish a new connection to Melisearch. So here it is, Melisearch communication error. That's why what I said, but we will fix this in the upcoming chapter. Let's make sure that we can also reach the backend. So here, the backend starts at API / and let me do health, because we have an endpoint that tells us if the backend is alive or not. So as you can see, we are receiving OK, which means that this is working. We can confirm this in the main file. We have this endpoint API / health, and yeah, it means it is working. If you followed the previous subchapters, you shouldn't get a bad gateway error. But if you do, that might happen because of the Nginx user. It doesn't have the full permissions to access the Unix socket file. Remember, the Unix socket is here. You can see that it is called junicorn.sock. And if we try to, let's look at the permission. So if we do ls-la junicorn.sock, here is what we have. I want to correct a mistake that I made in the previous video. So here, the first 3 characters are for the current user. So the current user is Imad. If you are connected as root, then it's going to apply to root. The second 3 are for the group, and the final 3 are for other users. So the mod here is 777. Why? Because here we have 3 of them. So every person or every user can read, write, or execute this file. This is not good. We need to make sure to restrict this. This is why we didn't get bad gateway, because everything is open. Everyone can read this file. But we need to change this. Or maybe if you have a different mode, then you might get a bad gateway. Let's try to do this. So I'll change this intentionally just to show you how to debug this problem. Let's use chown and let's change the ownership to 700. And let's do it for junicorn.sock. What does 700 mean? So this is in binary, and let's take these three. The first character is 1, the second character is 2, and the third character is 4. If you sum those three numbers, it's going to give you 7. So if all of them are on, if you want to allow read, write, and execute, you put 7. If you don't want to allow anything, you put 0. So here it means that for the current user, it can do anything with this file. But for the group, they can't, and for other users, they cannot do anything with it. If you want to allow people in the group to just read the file, maybe read and execute, in that case, we will put 5 because 4 plus 1 is 5. Let's do this. So chown. Okay, so it said operation is not permitted. Let's use sudo. Okay, that worked this time. Let's go back to ls-la. Sorry, I did chown. I should have changed this to chmod because these are called mods. So yeah, this time it worked. Let's do ls-la, and as you can see, it changed. Let's verify that. So the three characters here for other users are not available, which means they are set to 0. The second three are read and execute. That's 5. And the last three for my user is 7. So I can do whatever I want with this file, but other users cannot. So this is very important. And remember, Nginx is not inside this group. It's not my user. It's www-data. Okay, now let's try to do this. As you can see, we get the 502 bad gateway error because Nginx is trying its best to send this request that I am trying to make to API/health to JUnicorn. Let's go back to the slides. It received /API/health. It tries to send it to JUnicorn, but the Unix socket, we changed the mode now to not allow Nginx to do anything with it. So that's why it was blocked. And if it is blocked, then it's going to display this bad gateway error to the user. Now, how do we solve this? So we can add Nginx to my group. That will solve the issue. If you want, you can set it to 777. But that's not secure. Any user can do whatever they want with the file. Let's add www-data to my group. And let's also let's look at the error logs. I want to see what we have there. As you can see, we also get something in the error logs. Great. So this confirms, as you can see, it says critical, permission denied. So it tried to connect to the socket, but it failed because it doesn't have the full permissions. Awesome. So this confirms that changing the mod will either allow Nginx to be able to connect to the socket or not. So let's fix this. We have different ways, but I will do it in this way. So I will just use this command, sudo user mod -a-g, and here I have this. Put your user. My user is Imad. I will put it here, and I will add www-data to my user. Now we have another command called get end group, and here put your user. And as you can see, you should be able to see www-data. Awesome. So this confirms that it works. Now let's run. Let's do that ls-la, and www-data is part of my group. So it is a let's see. So we have this tree. So it's able to read and execute. Okay, let's go back to the browser. Let's refresh. It is still not working. Maybe let's try to reload Nginx. So here, hit Ctrl R and start typing reload. It's going to find it in the history. Hit enter. Let's reload. Okay, we are not able to connect to the socket. I want to go back to ls-la, and let's do it on JUnicorn. And here we have a problem because before I ran chmod and that changed the user to 750, and that's not correct. So we need to fix this. So let's do sudo chown. I want to own this file, not 750. 750 is not correct. So that was a mistake that I did because instead of typing chmod, I typed chown. And here, let's do it on junicorn.sock. Let's run ls-la. Okay, now that's fixed. Okay, let's go back again to the website. Okay, it still doesn't work, and maybe because we also need write permissions. So that's how you debug this. Let's do it. So let's go back to here, and let's change this to 770. Let's look at ls-la. Let's go back to the web application. Okay, now it worked. We need also write permission because we need to write to the Unix socket file. That makes sense. We write data to this file so that Unicorn can read it. And again, Unicorn will write data to Unix file so that Nginx can read it. Okay, great. So that works. And as you can see, the other users will not be able to reach this file. If you followed the same steps as I did, you should be able to get this to work. Awesome. So we have finished with the first part of this video. Now we will talk about security headers. We saw that we were all already secure because we have the firewall. It was blocking port 80, but now we allowed port 80 so that we can access the website. But security doesn't stop at the firewall. Browsers have built-in security features, but they only activate them if your server tells them to. And if you want to read more about this, you can go to HTTP security headers, and you will find this documented here on the developer Mozilla website. And as you can see, they have a lot of headers. They will explain them to you in detail, but I will show you, because we have a lot of headers, I'll just show you the main ones that we need to have. And there are also websites like securityheaders.com and the HTTP Observatory from Mozilla that will test the security headers to see if they are on your website or not. If they aren't, you will get a low score, but if they find them, then they will tell you that your website is secure. Same thing with security headers. You just need to paste here your domain name, or in our case, we don't have a domain name, so we could try to put just the IP address. Let's try this. Let's try it here. I'll try it on HTTP Observatory. So it says that it cannot scan IP addresses. Okay, so that means that we need to do it with a domain name. Okay, but here, let me actually take the full link. Yeah, it doesn't work. So with HTTP Observatory, we need the full domain, but I can use my own website. Let's try to scan it. And as you can see, I get A+, which is great. It's even higher than the 100. So the security here is great. But let's go back to security headers. This is the website that we are working with. We have created the new configuration, but you can see that it lacks a lot of headers. Here, the great thing is that they show you the main ones. They have the list of missing headers. They tell you why you need them. And here, F. So F is the lowest score that you can get, but you can climb from F to A+. And here, what I like about HTTP Observatory is that if you click on scan history, they show you the progression. So in the beginning, I got D because I wasn't aware of these headers, or I didn't add them in the beginning. But after that, I started to add them gradually to make my website secure. And now I have the highest score, which gives me the A+ grade. We will do the same thing for this website that we created now. Yeah, let's start working with these simple ones because the complex one is CSP, Content Security Policy. That one we will leave it at the end because it requires a lot of iterations to get it right. Now let's go back. Again, hit Ctrl R. Let's do sudo nano. Okay, we find this is the configuration. We will start with strict transport security. This one forces the browser to always use HTTPS when talking to your website. And here it will force that for the next 2 years. So this value is 2 years. You might be asking, we don't have HTTPS yet. We are just on HTTP. That's not a problem because this header is ignored by browsers if they see that you are accessing the website over regular HTTP. That's fine, but this will be active, or it's going to be used by browsers when we switch to HTTPS. So keep it like that. And here we want to also include subdomains. We don't have that, but if you plan to add subdomains, then we will also want to include them. Okay, so this is the first one. Now we can, let's save the file. Hit Ctrl X. Remember, we need to do sudo nginx-t. Okay, it says successful. Now we can reload Nginx. Now let's go back to the browser. Let's scan the website again. Okay, so yeah, it didn't change because that header wasn't in this list. That's fine, because now we will add Xframe options, Xcontent type options, and another one called cross-origin resource policy. I'll copy all of them. I'll go back to Nano. Let's go back to Nano, and I will add them here. So here I have some comments. If you want them, I will just remove them from here, but they are in the markdown file. Let's start with CORP. This one allows sharing. So if you want to allow other browsers to share your resources, then you can leave it this way. Otherwise, you might need to block it. And to do that, you just need to copy this header, go back to the browser, search for it. You will find the Mozilla the documentation there. And here, as you can see, you have an explanation, and you also have the directives that you can set. So you have same site, same origin, or cross origin. In our case, we are using cross origin because we want to allow other websites to maybe link our articles, images, or something like that. But if you want to block them, you put same site, which means that you allow only yourself to reuse some of your resources. Okay, let's see what we have in Nano. And as you can see, we allow other origins, and origin means other domains. I will remove the comment because I don't need it. We have here anti-click jacking. We use Xframe options for that. If you want to read more about click jacking, you can find this Wikipedia page which explains it. Basically, this is how the attack works. So the user is presented with a false interface where their input is applied to something they cannot see. You might visit a website. They will show you this page where you see they are telling you claim your prize, but this page is layered on top of another page. So when you click on claim your prize, you are not clicking on this button. You are clicking on another one which is invisible to you. And here they say confirm bank payments. So they can do shady things. They can take your data or something like that. So that's a problem, and we don't want to do that. We want to prevent this. To do that, we add Xframe options, and we tell same origin. As you can see, we are not using cross origin or other directive. Let's look at the other directives quickly. Let's search for it here, Mozilla. Okay, so here this is what we have. So we have either deny, same origin, or allow from origin. Awesome, so we have that. We also have meme sniffing. This one forces the browser to strictly trust the file type declared by the server. Sometimes attackers might upload malicious files, maybe like a script, but they might tell the browser this is not a script, this is an image. And this is called meme sniffing. Meme means the format types. So let's search for meme. If you are not familiar with meme, let's search for meme type. And yeah, it's media types. So this, it can mean fonts, images, text, scripts, etc. So attackers will trick your browser to think that that script is an image, and in that script they might load some malicious code or something like that. So we want to deny this. We don't want them to sniff the file types. We added 3 extra headers. Now save the configuration. Let's do nginx-t. Everything is good. Let's reload. Nice. So let's go to the browser. Let's close these tabs. We don't need them. Let's scan. Great. Now we have D. So you can see that we have 2 green check marks, but we need to add another ones. These 2 are simple, so let's add them, and let's leave CSP at the end. Okay, and let's add the headers just below them. So here we have, this one is for privacy. When a user clicks a link on your website, for example, if I link maybe a Wikipedia article on my website, if a user clicks it, the browser will send a referrer header to the new site. So if you want to protect user privacy by only sending your root domain name, not the full URL path, you can do this. So this then here, if they click on that Wikipedia link, Wikipedia will only see my domain name. They will not be able to see the full link. So yeah, we can add this. And here, this one is simple. So if your website doesn't require using camera, microphone, geolocation, payment, you can disable them because these are things that I don't want. And that's great. So if someone tries to maybe hack your website and enable the user's camera, that will not happen because we are blocking that with the help of the permissions policy header. Now save, exit the file, verify that the configuration is correct. Now reload. Let's go to the website and let's refresh. Awesome, so it says C. And in order to jump from C to A+, we need to work on CSP, which is the final boss. This one is complex, but I'll show you how to do it step by step. Okay, let's go back to our website. So this is the front end. Everything looks good. Let me open another tab. I want you to search for this. So you find it here, and we also you can also see it here. So yeah, if you want to read more about cross sites, that's not what I wanted to search for. I wanted to search for Content Security Policy, CSP. Yes, here it is. You can see that this article is very long because in order to build it, there isn't one CSP that everyone can use. This depends on what you are using in your website. That's why you need to build it progressively. Open your website. So I will delete the tab that we don't need. Okay, we just want these two. Now we are in Chrome because here we have the ability to change this CSP very quickly. I'll show you how to do this. Now I want you to look at the very top of the network request list. Here we don't have a domain, that's why we have just the IP address. Right click, show all overrides. Here I will start fresh. Now let's click on select folder for override. So I will create one here and select it. And let's allow this. Now go back to network. Here I want to click on override headers. Yes, that worked. And here let's add content security policy because this is the one that we want to work with. And here in the header value, let's start with default source and let's do none. And let's not forget the semicolon. Now hit enter. Now I want you to click on the .headers file. Here it should say star because we want to apply it to everything. And let's refresh the page. Okay, you can see that we cannot view the website. And we have a lot of errors. So you can see that here it says refused to load the image, refused to load the style sheets, refused to load the script. So now that's what we need to do. And also make sure if you want, you can open this .headers file in a text editor so that you can change it here easily. I'm opening it in Sublime and yeah, I see the same thing. So I'm applying it to everything and I am just playing with this header. And default source none will block everything. So this is the strictest CSP, and as you can see, it doesn't work. But we start from here and we start relaxing it in steps. So you can see that there are many things that are blocked. There are images that are blocked, some styles. You can see that this image comes from our origin. So this one is fine. Let's see, here we are blocking this side sheet because it comes from Cloudflare. So this is not our website, it's coming from another place. But we know that we need this, so it's awesome. So we can keep it, that's not a problem. But this will show you the things you will decide. Do you want to keep it or block it? Same thing for scripts. These are all coming from our assets folder. So yeah, these things can be kept. But if we see that there are other strange things, we need to decide if we should keep them or not. So let's start with the images. So I will come here. You can see that here, default source, I will change it from none to self. I saved the file. Now I'll go to the browser. Let's refresh. So that's solved a lot of problems. Why? Because you see that we don't have assets, the image was loaded because those things were in our dist folder. So when we built the website, we already had those images, those style sheets, everything was there. So when you use self, it means our origin, everything in our origin should be allowed to load. Now we have different errors. So forget about these ones because as we saw before, we don't have melee search, that's why they are failing. But focus on these. Now we cannot load this font. So this is the font that we are using in our website. Yeah, let's fix this one. Go back here and we have another directive. We need to come here. Let's add a space and let's put style source. This one will allow us to load styles. Again, we can start with self, and if we want, we can add more things here. But let's save this. Let's go back to the website. Or instead, let me put it here and let me load Chrome like this. Yeah, that's better. And I will move this panel to the bottom. Now I've saved this. I will refresh the page. We still have some problems with Google, so we will copy this link and place it here. We need just the origin. We don't need the full URL. So we can see that the origin is fonts.googleapis.com. That's what we need. Now save, refresh the page, and as you can see, now we are able to load the font. We don't have any error. Now we have another style sheet issue, but this time we will just take this domain. Take it, copy, and let's add it after Google. Let's add it here before the semicolon. Save, refresh the page. Awesome. So now we are able to load the font awesome icons. We are able to load the font. And as you can see, we don't have those errors, but we have different errors. So here we aren't able to load the font URL because it violates the following default source self. Okay, so you can see that here we don't have, let me decrease the font size. We have default source, we have style source, but we haven't yet added font source. So let's do that. I will come after the semicolon. I will add this and I will add another semicolon. Save this, refresh the page. Okay, so let's open this and let's see what's happening. So again, we have the same origin. Let's copy it. Let's paste it after self, save, reload. Okay, so we have a different domain that's coming from JStatic. That one is fine. Again, if you see that there is a domain or an origin that is suspicious, then you feel free to block it. But if you think that this is something that you are using and it comes from a reputable website, it's not something suspicious, then add it to the list. So now we solved the problem with fonts. Now let's look at images. Okay, so here we have some SVG files, and in order to keep those, we can just add data. I will come, where is it? Do I have image source? No, we don't. And here they are telling us. So note that image source was not explicitly set. So again, let's do the same thing. I will copy font source. I'll come here, and here I'll need to change it to image source. Save, reload. Okay, that still doesn't work because we need to add this. Here we don't have a website, but we can add here. Where is image? Let me make this smaller. Yeah, it's here. I can come after this and add data. Let's refresh the page, and voila! As you can see, we were able to fix every error, and now these are just coming from the backend. But we are not done yet. What you need to do is to test your whole website. Make sure to click on every single page, see if the errors are, if you don't see. The goal is that we should not see errors coming from here. Okay, so as you can see, we have other problems. Okay, so we have inline style issues. Let's go back to Sublime Text. I want you to find style source. Do we have, yes, we have style source. So we have self, fonts.google, and here. So I will add a space at the end because here they say that we are using, so yeah, we are using inline styles, but this is blocked by default. So we need to add unsafe inline. Let's save it first and let's reload the page. Okay, we have 0 errors. Great. But this is unsafe. Here's the thing, even though this is unsafe, it's fine here in our case. Because in our Vue.js application, or maybe you might be using React or other frameworks, you are using inline styles or inline scripts, and those are fine because if you don't do those, your application won't work. But yeah, by default they are blocks, but we can add them. Let's continue testing the application. Let's go here. Okay, that's fine. So the other pages are not working because they need to communicate with Mail Search. But at least every other page is working correctly. Good. Now, after doing this, we can, let's copy the value. I'll hit Ctrl X. I no longer need this, so I'll clear this. I'll just keep this. Now I'll go back to Nginx. I need to update the configuration. So let's do that. I will come down and here I'll type add header. It's going to be content security policy. I'll add quotes and I'll add the other ones. As you can see, I have added the CSP. I'll save the file, I'll exit. Let's verify that the syntax is okay. And it isn't, so this is why we need to do this. Let's go back. I forgot to add something at the end. Yeah, I forgot to add always. And why do we do this? Because we want to send this header in all response codes. So if we get 200, 201, 300, all of them. So this header will be there. And we can also add something here at the end. I'll add another semicolon. I'll add upgrade insecure requests. This one, again, forces the browser to change from HTTP to HTTPS. Now we have HTTP, so this doesn't matter, but later, after adding SSL certificates, stuff like that, we will be able to have HTTPS. Now we are just preparing. Save the file, exit, verify. Okay, the syntax is okay this time. And let's reload Nginx. Okay, so this is the moment of truth. I will take this, let's put it here. We need to make sure that the website loads correctly. And it is loading. Let me move this to the left. I will clear the logs. I want to go to the other pages. Yeah, everything seems to be working perfectly. Okay, so now let's scan again. And yes, we got A. Maybe on Firefox might have gotten A+, but this is the highest score that we can get. And as you can see, everything is green. And this is the response that we received. So as you can see, this is what we have added. Here is upgrading secure requests. And yeah, they're also telling you if you want to add other requests, but this is the bare minimum. You need to have these. And as you can see, most of them are easy, but content security policy is the one that takes time because it is unique to each website. Your application is now live. Nginx is serving your Vue frontend and routing API calls to your fast API backend. However, we haven't yet configured Mail Search. This is a search engine that I am using to allow users to search for articles. It's similar to Elasticsearch, but it doesn't consume a lot of memory. So we are going to configure that in the next chapter. But if you don't care about Mail Search, you can skip to the other chapter number 4, where we are going to create our domain name, add SSL certificates, and make our websites secure by making users access it through HTTPS instead of HTTP. See you in the next chapter.